Get the grass patch.
All right, so all we're gonna do, go over homework. We got one thing to learn, and don't forget, on Monday, we have a quiz on integration by parts. I made the quiz this morning. There's 5 problems. I guess it'll be 6 points each. Or should I make it just 5 points each and you get 3 points? All right, and then I would say 2 out of the 5 you can do tabular. But the other 3, you gotta do it the normal way. Now remember, you can't do tabular on every single problem, only certain ones. And after you did the homework, you should know which ones, right? Okay, we have questions?
Oh, you just erased 30.
I erased it.
Not important.
Oh, that's a shame.
25, 31,
Right, 25.
and QQ.
Now remember, this next test is only gonna cover 2 sections, 7.3, 7.4. Today we start 7.4, and we're gonna spend 2 nights on it as well. Whoa! Other class didn't have this many questions. Doesn't matter, we're still gonna finish early. 25. Integral from 0 to pi over 2. Now remember, I told you about these directions. Don't pay attention to the directions, just compute the darn integral, right? Okay, so when you first look at this, you gotta ask yourself, can I do tabular? Does tabular work on this? Yeah, it does. So x squared sine 2x, take the derivative down to 0. So 2x, 2, 0. This column, you take the integral or antiderivative, so what? Negative half cosine 2x. Negative 1/4 sine 2x. Positive 1/8 cosine 2x. And then you just go boop, 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 plus, minus, plus. And then you're ready to write down the answer. So this times positive 1. So negative half x squared cosine 2x. Then the next term will be this times negative 1. So plus 1/2 x sine 2x. The next term going to be this times positive 1. So plus 1/4 cosine 2x. And normally we just put a plus c and we're done, right?
No.
Except this is a definite integral, it has limits. So then we just go boop, boop, 0 to pi over 2. How come I don't write the plus c? Because it's going to cancel out. Now if you want to write the plus c, you can, but it's going to cancel out. So we know better already. Okay, do you need me to plug in the numbers?
Just
Yes.
Alright, if I plug in the first number, you're going to get, this is pi squared over 4 times half,
So pi squared over 8.
pi squared over 8. And then if you plug it in here, cosine of pi is negative 1, the negatives cancel out, so you just get pi squared over 8 then, right? Plus, if I plug in pi over 2 here, 2 times pi over 2 is pi, sine of pi is 0, so that's 0. Here, 2 times pi over 2 is pi, cosine of pi is negative 1, so you get negative 1/4. Minus, plug in 0 here, you get 0. Plug in 0 here, you get 0. Plug in 0 here, cosine of 0 is 1, so you get 1/4. You know what a common mistake is? A lot of people think if you plug in 0, you're going to get 0. No, not all the time, because cosine of 0 is 1. So don't just assume that if the limit is 0, you plug it in, you get 0. And then you know what's another common mistake? Cancel out the 1/4. No! Because that's a negative 1/4, and if you distribute this negative sign, that's a negative 1/4. So they do not cancel out. Yeah, I'll leave the rest to you. 31. Okay, now this problem is the same as this problem right here. I'm just going to rewrite it like this. Right? Because if you're given the derivative to find the original function, you have to find the antiderivative, which is the same thing as this. And then they give you a restriction over here. And you know what this restriction is for?
Oh, so that when you do the derivative, the absolute.
The absolute value. Okay, so can I do tabular on this? Does tabular work on this one?
No.
No, so this one we got to do it the normal way. So on Monday on your quiz, you're going to have to do 3 of them the normal way like this. So you have to put the secant inverse over here because we don't know the antiderivative of secant inverse x. We don't know. So that's the way it goes there. And then now, to go from here to here, you take the derivative. 1 over, do we remember it? Absolute value of x, square root of x squared minus 1 dx. But because of this restriction, you don't need the absolute values. Because if x is greater than 1, the inside is always positive, we don't need the absolute value. So that's what it's there for. If there's a restriction, that means there's going to be an absolute value. And since we're AB, we want to make sure it's positive so we don't have to worry about it. And then to go from here to here, you do antiderivative. All right, so the integral of u dv, which is the thing we're trying to find, is equal to u times v minus the integral of v times du. Now, what happens when you multiply this times this? The 1/2 can be thrown outside. This x can cancel into one of those x's, so you're going to get this. Okay, so in order to do this integral, you have to be able to do this integral. And can I?
No.
What do you mean no?
Wait, well, you can use
It's not on the list.
Right, so use it.
U substitution. So if I make a u substitution for this, what would you let u equal to? U equals x squared minus 1. Du is 2x dx. Is that going to work? Yeah, because look, x dx, x dx. Remember, when you make a u substitution, whatever you let u equal to, du gotta be in the integral as well. Well, for the basic problems, and then there was a one later on where you gotta use a little tricky stuff there. Anyway, this stuff here, radical u in the bottom, x dx is 1/2 du, and can I do that integral?
Yes.
Yeah, that's like u to the negative half, right? So make the power 1 bigger, put the reciprocal in the front, plus c, the 2's cancel out, and then resubstitute back in. So you got square root of x squared minus 1 plus c. Okay, now we gotta write the final answer. So, starting with this, 1/2 x squared secant inverse x minus 1/2 of all of this. Because remember, see how I circled it to keep track of it? So it's going to be negative half times this. So it's going to be minus 1/2 square root of x squared minus 1. And then what is negative half times a constant?
It's the constant.
It's just a constant. Again, a constant times a constant is still a constant. So we do not write minus 1/2 c. We just write plus c because it's still a constant. Okay, so I'm telling you right now, on Monday's quiz, either going to get this problem, this one, which we did for homework, or this one, which we also did for homework. It's going to be one of these three right there. That's because when you get to this step over here, it's u substitution. You just got to prove to me that you can do it. I'm not going to even change it. It's going to be exactly like that. All right, next. 39. Where's 39? It's a multiple choice. Boo! Okay, look at that thing. Can I use tabular on that? Does tabular work on that one?
Yep.
Yeah! Because you got x, which you can take the derivative down to 0. And this one you can repeatedly integrate, right? So take the derivative down to 0. What? This side, antiderivative. Now, what is that going to be? Negative 1/5 cosine phi. Don't forget that 1/5 now, because that's kind of big points. -2 error every time you forget that. Do another antiderivative. Negative 1/25 sine 5x. And then, plus minus. And then now you're ready to write down the answer. This times positive 1. So it'll be negative 1/5 x cosine 5x. And then this times negative 1. So plus 1/25 sine 5x. And then don't forget to put the plus c. Yeah, if you can use tabular, do tabular because tabular is so easy. So like I said, what did I say? 2 out of the 5 on the quiz, you can do tabular. Okay, next, 43. Next page. What is the next page? Oh, this is the tricky one. Now, normally I give this problem on the test, but this year maybe I'm not going to put it on the test. unless I give you a hint. Now, they gave you a hint in the book. Now, if you look at this problem, you think, oh, you cannot do a U substitution with this, but you can, because it's a little bit, it has to be a certain type of problem. So, the hint they gave you is do a U substitution first. So, like if you were to make a U substitution, what would you do? U equals root x. But then the problem is, the derivative of root x is 1 over 2 root x, right? Yeah, but Mr. Park, there's no root x in the denominator there. How am I going to substitute for it? So it looks like you can't do it, but you can. Watch. What do I substitute for this? Sine u, right? Sine u. So far, so good. Now, what do I substitute for dx then? Right here. Here's dx. So what happens if I move it on this side? You get 2 root x du. Mr. Park, I can't do that integral because if it's du, that means everything needs to be u's. What am I going to do with that? Yeah, so,
Substitute.
yeah, substitute. Root x is u. See, root x, that's u. So if you substituted it in, it didn't look like anything was going to happen, but now you just have this now. Can we do that problem? Can I do tabular with that? Yeah, because it's up to you. You can put the 2 outside or you can keep it there. Let's just keep it there. 2u and sine u. Yeah, you can do tabular because you can take the derivative down to 0, right? Take the derivative. 2, and then you get 0. So yeah, tabular is going to work as long as you can integrate this 2 times. What's the integral of this? And then negative sine u. Doot, doot, plus, minus. So then, this times positive 1. So I got negative, so this is equal to negative 2u cosine u. And the next term is going to be this times negative 1. So plus 2 sine u plus c. Box that, that's my answer. No, that would be a minus 1. Because if your original problem is in x, the answer should be in terms of x. So now you got to resubstitute back in. So what do I substitute for the u? Root x. So your final answer should be negative 2 root x cosine root x plus 2 sine root x plus c. Box that. That's the answer. So that's a tricky one. And then finally QQ1 with a question mark on it. What? Oh, you guys forgot about slope fields, yeah? Because that was before vacation, yeah? That's going to be on this test, you know. Okay, number 1. Which of the following differential equations would produce the slope field shown below? Okay, here, I'm going to write all 5 down. Except the one on the test that you're going to get, it's not going to be multiple choice. You actually have to draw out the slope field. Do you guys even remember how to construct the slope field? Okay, all right, let's do a review because this is gone from the memory. Okay, suppose you have, okay, this is your coordinate axes. So what if I say construct the slope field for, let's say the first one then, at the indicated point. So like, here's a point. Here's the point 2, comma 1. What do you do with that point? You plug it in. You plug in 2 for x and 1 for y. So you would get dy dx equals 1 minus 3 times 2 is 6. You get negative 5. So at this particular point, dy dx, or the slope, is negative 5. So what you do is you just draw a hash mark that has a slope of negative 5. Cool! Remember that? And you do that for whatever points you need to. So like, what about right here? Here is the point 0, 0. What would happen if I plug in 0 for y and 0 for x? You get dy dx equals 0. So right at that point, the slope is 0. So, cool! Horizontal then. Okay, let's just do one more. How about this point right here? Here's the point 1, 1. What happens if I plug in 1 for y and 1 for x? What do you get? You get negative 2. So you draw a slope that has a hash mark that has a slope of negative 2. That's what a slope field is. So they are asking you, they give you a picture. I'm not going to draw this whole picture in, but which of these equations represents that slope field right there? So remember we did this before, so what can you do? Like pick a point, here's the point 1, 1 over there. What would okay, if I plug in 1 for y and 1 for x, what do you get? -2. But if you look at the picture, at the point 1, 1, the slope is like this. It's like it's positive, so this can't be it. We're looking for something that's positive. Okay? What if I plug in the point 1, 1 here? Plug in 1 for y, 1 for x. You get 4/3. Could that be 4/3? Well, it depends on the scaling. Yeah, it could be. We don't know. What about here? Plug in 1 for x and 1 for y. What do you got? You got 2/3. Could that be a slope of 2/3? It could be, so we'll leave it. Okay, plug in 1, 1 here. 1 minus 1/3 is 2/3. Could be, and then this will be 4/3. So we can't tell anything from that. So now, what about pick a point in the second quadrant now? Like, how about -1, 1? Okay, so we already crossed that out. Now, in the picture, the slope looks like this, so it's kind of like it's something negative. What happens if I plug in -1 for x and 1 for y? What are you going to get? -1, 1. 1 minus 1/3 is 2/3. Does that look like a slope of 2/3? No, so that can't be it. Okay, plug in -1 and 1. You get -4/3. Could that be a slope of -4/3? Yeah, maybe. Okay, plug in -1 there and 1. 1 plus 1, that's 4/3. That's no way, so that's all. And you just keep on doing it, eliminating until you hit the right one. Okay, what if you plug in -1 and 1? You get -1 plus 1/3 is -2/3. Could that be a slope of -2/3? It could be, so. Now you go to the third quadrant, pick a point there, -1, -1. Now in the picture, it looks like this, okay? Some negative slope. So if I plug in -1 there and -1 there, what do you get? -2/3, maybe. -1 there, -1 there, -4/3, maybe. Okay, so now we go to the fourth quadrant. Here's the point 1, -1. What's the slope? It looks like this. Okay, plug in 1 and -1. What do you get? No, you get 4/3. Possible. 1, -1. 2/3. Oh, so that's possible too. So what do we do?
Keep going.
Keep going. Pick a different point. Okay. What's a point that can be differentiated from all the rest? What did you guys do? No, but 0, 0. They both come out to 0. And it's 0 right there, so it doesn't tell us anything. What shall we look at? Somebody said 0, 1. Okay, 0, 1. If you plug in 0 and 1, you get, well, according, the book looks like this. If you plug in 0 and 1, what do you get? -1/3. Well, actually, in the book, it's kind of like, it's hard to see. It's kind of like that. So it could be, and what if you plug in 0 and -1? No, what are we plugging in? 0, 1. 0, 1.
Into E.
Oh, it's this one. 0, 1. 4/3. That is definitely not 4/3, so that's gotta be the answer.
The answer is E.
What? The answer is what?
E. It's the one you just.
Wait a minute.
It's E.
I wrote it wrong.
No.
This is A. No, E. No, this is C. I wrote it wrong. A, C, E,
Oh.
B, and D. What? So did I get it right?
Yeah.
Wait, what?
No, that's because I wrote it down. I thought it was A, B, C,
Yeah,
D,
you're
E,
looking-
but it was
you're
actually
looking
A, C,
right
E,
side.
D, D.
Oh, wow.
Good shit.
Anyway, that's how you do the problem. All right. Okay, now today's lesson we start 7 point. Now we're going to spend 2 days on 7.4. So I'm going to put it in the book here. And in the other class, I actually did some of their homework for them. Yeah, so I'll do the same thing for you. So now tonight's homework is only 10 problems. That's all it is, 10 problems. Okay, so what we're gonna do tonight is we're gonna be solving differential equations. Now, we already know how to solve differential equations, look. dy dx is equal, let's do a simple one. X squared, have 3x squared, and initial condition y equal 1 when x equals 2. Okay, so if you know the derivative, how do you find the original function? You just find the antiderivative, right? What's the antiderivative of 3x squared? Come on, easy. Make the power 1 bigger. Put the 1/3 in the front, but it cancels the 3. So it's just x cubed plus c, right? That's what a differential equation is. A differential equation is an equation that has a derivative in it. See, this is a derivative. And then what you have to do is find the original function. That is called the solution to the differential equation. Now, what am I going to do with this information right here?
Plug it in.
You use it to figure out the value of c, right? Right before vacation, we took a quiz on that, right?
Yep.
So if I plug in 1 for y and 2 for x, 2 to the third is 8, you can figure out the value of c. c is equal to -7. So the solution to this differential equation with these initial conditions is y equals x cubed minus 7. Easy, right? And the reason why it's easy is because there's only x's over there. There's only x's. But the kind you're going to see tonight, you're not going to have x's, just x's. You're going to have x's and y's. So this is like the easy kind. All you got to know is just find the antiderivative. But now we have to think more. So this is the kind you're going to see tonight. dy dx equals, okay, what shall we do? 2xy with the initial condition, no. Let's make it a little easier than that. How about 3x squared y? Yeah, I like that better. Y equals 2 when x equals 1. Okay, those are your initial conditions. Okay, so can I just find the antiderivative and write it down?
No.
No, because of that y there. It didn't have that y. It would be easy like this. But it has a y there. So what do we do when there's both x's and y's here? Well, the first thing you have to do is separate the variables. In other words, since you have a dy over here, you have to bring this y on this side. So if I divide by the y, you get this. You just have to do algebra. And then this dx, you're going to put it on this side of the equation. So multiply both sides by dx, and you get that. So you see what it did?
Yes.
Okay, so this is called separating the variables. Okay, so if you have x's and y's here, first step, separate the variables. All the y's go on the left with the dy, all the x's stay on the right with the dx. Next step, integrate both sides. Okay, what's the integral of the left side? Natural log, absolute value of y, plus c. Now I'm going to put plus c1. And you'll see why in a minute. Now, what's the integral of the right side? No, integral, no, not derivative.
Oh, 1 or x cubed.
X cubed plus c2. That's because this constant and this constant, they might not be the same. Okay? But anytime you take an antiderivative, you have to put a plus c. There's a constant there. This constant and that constant are probably not the same. Okay, now watch what I'm going to do in the next step. I am going to mush these two constants together into just one constant. Because if I move this constant to the other side, you're going to have c2 minus c1. But what is a constant minus a constant? A constant. So we just make one. We mush them together into just one. Okay, now, the next step. What do I do with this absolute value? Well, again, how do you handle absolute value? If the inside is positive, you just leave it alone, right? It's y. But if the inside is negative, you negate it, right? So how do you tell? Well, you look at your initial conditions. Look, you're going to be plugging in 2 for y. Isn't 2 a positive number?
Yes.
So we can take away the absolute value. Like that. So there's a lot of things going on here. Okay, now we need to figure out the value of c. Can we do that?
Yes.
Yeah, you plug in the initial conditions. So if I plug in 1 for x and 2 for y, you get natural log 2 is equal to 1 plus c. So we just figured out the value of c is natural log 2 minus 1. Okay, so what do we got so far? So if I plug that in for c, you have natural log y is equal to x cubed plus c, but we just figured out c is natural log 2 minus 1. Okay, we're almost there. All you have to do now is solve for y, just like over here. See, if you're given the derivative, the solution is like y equals something. This is the solution. So what we need to do is we need to solve for y. So how do I solve for y here? How do I get rid of this ln? You e both sides. Now multiply by e, you e both sides. That's because e to the natural log y is simply y, and then you get e to the x cubed plus natural log 2 minus 1. This whole thing is the exponent now. Now that is the correct answer. However, on the AP exam, this is going to be a multiple choice problem. You look at the choices, none of them is that. You have to simplify that. Now how do you simplify this?
E to the x cubed plus
E to the x cubed
times
e to the natural log 2
times
times e to the negative 1, because when you multiply things together, you have to add the exponents like that, right? And then what is this right here? What is e to the natural log 2? That's just 2. So you get 2e to the x cubed minus 1. That's your answer. I guarantee that's the one they're going to have as one of the choices. Yeah, so anytime you have e to the stuff, you're going to have to simplify. That's probably the hardest part of the problem. So how do you solve differential equations when you have both x's and y's in it? Separate the variables, integrate both sides, mush the two c's together into just one c. Now, it doesn't matter if you put it on the left or the right, we just normally put it on the right. Then you plug in the initial conditions to figure out the value of c, and then the last step is solve for y. It's the same process every single time. The only thing that's going to change is when you do the integrals, you're going to get different functions. Okay, so let's do 2 problems from your homework, and then we'll go to lunch. Okay, so tonight you got 10 problems. I'm going to do 2 of them. In fact, let's do even problems, right? Okay, number 4 looks good. No, we just did a problem just like that. Let's do number... Yeah, let's do number 6. dy dx is equal to cosine squared y with the initial condition y equals 0 when x equals 0. So the first thing you notice, hey, there's a y here. I'm going to have to separate the variables. So what you got to do is you got to move all the y's on the left side with the dy. So dy over cosine squared y equals...
We're looking for water for hours.
What is going on? Who is hacking my computer? Where did that come from? Star Advertiser? Yeah, that was it. Equals, and then this dx needs to be moved to that side of the equation. Can you guys do that?
No.
What do you mean, no, this is algebra. Look, to move this on this side, you gotta divide by, right? To move this on that side, you gotta multiply it by it. Put all the y's on the left with the dy, put all the x's on the right with the dx, except there's no x, so it's like 1, right?
Oh, okay, okay,
Yeah.
okay.
Okay, next step, integrate both sides. Okay, what's the left one? The other class had problems with the left one. What's the integral of 1 over cosine squared y? Okay, so therefore, what is 1 over cosine squared? Secant squared, is that on the list? Yeah, it's just tangent y, that's right. Yeah, but a lot of people, you know what the other class said? Change this to 1/2 plus 1/2 cosine 2. No, yeah, if it's in the numerator you do it, but not in the denominator. And then some people said, oh, natural log absolute value of cosine squared y. That's a double no. No, 1, just because it's 1 over, that doesn't mean it's natural log, you know. The only time it's natural log, see like, here, 1 over y to the first power, that's natural log, when it's to the first power. Second power, no. So what you have to do is change 1 over cosine squared to secant squared, and then that's easy, right? Plus c, I'm not gonna write the plus c because remember we're gonna mush the two together. Okay, what's the integral of 1 dx? X plus c, and then we mush the 2 plus c's together into just 1 plus c on the right. Now, once you get to this step, plug in these numbers to figure out the value of c, and then your book made it easy. What happens when you plug in 0 here? Tangent of 0 is 0. 0 plus c, we just figured out c is 0. When I write problems, I make sure that c doesn't come out to 0. You know why? Because then the people, yeah, exactly, the people that don't put the plus c gonna get the problem correct. And I guarantee on the AP exam, they will never make c come out to 0. So you have to be able, you gotta know that there's a plus c there. And then the last step, solve for y. How do I solve for y? Divide both sides by tan? No, you tan inverse both sides. Bam, that's your answer. This is the solution to this differential equation. Okay, one more and we're going to lunch. Yeah. Okay, which one looks challenging? We did 6 or 8 or 10. Let's do 8 then. Number 8. dy dx equals e to the x minus y. Initial condition y equal 2 when x equals 0. Okay, so I see a y here, so the first thing I gotta do is I gotta separate these variables. So how do I do that? That's the hardest part of this problem. How do I put the y on the left? No, you can't natural log both sides because this side could be natural log of dy dx.
You separate them.
Okay, I heard somebody say it. Split this up into e to the x times e to the negative y, because then you would add the exponents to get that, right?
Right.
Okay, now you can see, once you write it like this, now how do I get rid of this? Divide it, so you get dy over e to the negative y equals e to the x dx. Okay, can we do that? Okay, now what's the next step? Integrate both sides. Okay, what's the integral of the left side? And don't say natural log e to the negative y. That would be a very critical error. Okay, well, 1 over e to the negative y, isn't that just the same thing as e to the y?
Yeah.
Okay, so what's the integral of e to the y? E to the y plus c. But we're going to hold off on the plus c because we're going to mush the 2 plus c's together. And of course that is e to the x plus c. Mush the 2 c's together into 1 c. Now when you get to this step, plug in your initial conditions. Plug in 2 for y and 0 for x. So e to the 2 equals e to the 0, which is 1, plus c. So we just figured out c is e squared minus 1. That's the value of c. So put that in there. So we got e to the y equals e to the x plus e to the second minus 1. Okay, the last step. Solve for y. How do I get rid of an e? You natural log both sides. The natural log of e to the y is simply y. And remember, when you natural log, you gotta natural log the whole side now. Now, can I distribute the natural log? No, you can't. If you did that, that would be a big time. You cannot, just like cosine, if you have cosine, can I distribute the cosine? Some of you thinking, no, you can't do that. You can, no, you cannot distribute. This is your answer, people. So, if you were to distribute the natural log, yeah, you would get some major points off of that. Yeah, you gotta know your properties of logarithm. So, every single problem is the same thing. Just follow the steps. Separate the variables, integrate both sides, mush the 2 c's together, plug in the initial conditions to figure out c, and then the last step, solve for y. There's actually only one step involving calculus. That's when you actually do the integral right here. Yeah? All the rest is just algebra. All right, any questions on that? All right. Oh, 15 minutes early. Okay, now if I excuse you early, do not disrupt the other classes. All right, we'll see you on Monday, and don't forget the quiz.